Hello and welcome. This video is on the script library. R-Instat has a script window so users can run R scripts easily. Here we show how simple it is to run a script from an R package or one that has been written for you. This presentation shows another component of R that makes it such an impressive resource. In R-Instat, we have been using just a few of the more than 20,000 packages that extend R's core capabilities. They add to R in three different ways. First, they add new commands to R, then they provide datasets, and they provide scripts. Some R packages don't provide all three, but with 20,000 available, that's maybe a relief to you rather than a problem. Here we introduce a few of the scripts. First, use the R-Instat data library to show you where the scripts are in each package. Go to File, Import from Library, then Aggregate, and the example called gomez.nitrogen. Press OK to open the dataset. There are 96 rows of data and 4 variables. To get more information about the dataset, look at the R help. Return to the Import from Library dialog and choose the R help button. The top of the help gives details of the data, but we are interested in the script. Scroll towards the bottom to the last section, Examples. By examples, it means examples of scripts. Here we show the start of the script. This gives the author's analysis of the gomez.nitrogen data and is what we use here. This activity will show you how to make use of these examples in R-Instat. These scripts don't use the R-Instat data book, but you don't need the data in R-Instat or even the data window. So, close this help window and also close the Import from Library dialog. Use File, Close Data Book so there is no data in R-Instat. As the data window is not needed, the log/script window can be enlarged. So, use View, Swap Data and log/script. Now half the R-Instat window is for the scripts and the other half is for the results. In the script window, press Insert and go to the Library tab. Choose the aggregate package and the gomez.nitrogen data. Then press either OK or to script. Let's start by renaming the script window. So, double-click on the name and call it nitrogen. Earlier we suggested you should become a data detective. It is useful if you also become a script detective. Now examine the script a bit. We would like you to become a trainee script detective. The script is well laid out with comments throughout, and that gives some confidence in the script. In case that sounds scary, being a script detective, by our definition, is easy. What is your initial impression as a trainee script detective? It is about 50 lines long, though that includes some blank lines. I suggest you can feel positive about this script. It is nicely commented and well laid out. It analyzes data from a 1984 book by Gomez and Gomez. This book was written before R started, and the comments explain that the script emulates the book's analysis. It claims to produce tables 6.16 and 6.18. We'll soon see if we can do that with R-Instat. Let's start running the script. At the top of the script, mark the first section as shown and press Run. It worked! The result is not yet exciting, but at least there was no error. Go to the next comment, mark the section as shown, and press Run. This gives a graph with 9 facets. We are more interested in scripts than analysis, but the top row of graphs shows a large difference in soil nitrogen at the 3 crop growth stages. In contrast, the middle and bottom rows of graphs don't show similar differences due to the 8 nitrogen treatments or the 4 replicates. Now, mark statement by statement and press run each time. The first statement gives another graph. R runs one statement at a time. You notice that we are currently just showing comments from the script and the results in the output window. Now you are running a script, you may like to include the R commands in the output window also. If so, then go to the toolbar and click on the output window icon and select to show the R commands. The next section is 2 statements. Mark it and press run again. This produces an overall analysis of the data called an analysis of variance table. You may notice that the line labeled stage in the table has 2 degrees of freedom, corresponding to the 3 growth stages and very large sums of squares and F value. This corresponds to the large differences shown by the top row of the graphs earlier. The final part can be run together. Mark it and press the run button again. Then in the output window, press maximize to look at the results in the full window. This is apparently table 6.18 in the textbook. It breaks down the earlier overall analysis. It takes a bit of statistics for the interpretation and shows that nitrogen treatment 7, we are not told what they are, is the most different to the others. This shows how easy it is to run a script. Try one more. This time, use the agricolae package. Press the New button, then the Insert button. In the library, choose the agricolae package and then go to the Function button and look for ssp.plot. Function is the same as a command. Then press OK or to script. This is a popular package for the design and analysis of agricultural research data. This package includes R commands, datasets, and scripts. Many R packages do this. Now, as a script detective, notice it is 34 lines long. Here there is a big comment at the start of the script, but then no further comments to describe the steps in the analysis. The word plot in this script is confusing, particularly if English is not your first language. When used as split plot or split plot, it is a plot of land in a field. That's fine until line 24 in the script when there is the plot command. That is plot as in a graph, so very different. The dataset is called SSP for split plot. That's also a bit confusing because his special function for the analysis is called ssp.plot. So, perhaps we feel slightly less clear about this script than the first one, but let's try anyway. Go to line 1 and press run. You see that however many comments are at the start of a script, the run button goes up to the first command or statement and runs that. Now continue to press the run button repeatedly until and including the first line starting plot. Look carefully at what happened on lines 18 and 19. Did you notice this has multiple commands or statements on the same line? This is the opposite of what we have seen earlier, when we split a single statement over multiple lines. Having multiple statements on the same line is unusual. Press run again to get the second and then the third graphs. These graphs show the groups and the interquartile ranges. It shows that as the nitrogen and management increase, the yield also goes up, though variability also increases at the top end. The variety also impacts the yield. However, this analysis does not provide any insight into how these factors interact with one another. Mark the last block from the comment as shown and press Run. Press Maximize to have a bigger view. This produces an overall analysis of the data called an analysis of variance table. The results largely confirm the simple graphs, namely that the effect of each of the three factors is large. The only interaction term that may be of interest is between nitrogen and variety, but that is minor compared to the main effects. You can use Run All, but we don't recommend that, as we like interactive statistics. Run All is efficient, but it does not encourage users to spend time looking at the graphs and results as they get them, and thus make mindful decisions. Our goal is good data analysis, and this requires thinking about each step of the analysis. We are less worried about computational efficiency.